All right, so you're welcome to this section's class, and this is going to be an intro to the advanced section, and I believe it's necessary I walk you all through this so that you can actually um, get the basics from your previous class, so that you don't get any more confused when we have to dive into the advanced queries. So here we're going to be looking at some of the basic queries that exist with regards to um, advanced database. And so I hope you're able to, catch up and then get something out of it. So let's move to the slides. Okay, so SQL or SQL or structured query language, which is the full meaning for SQL. It's a standard language for relational database management system. So what is a relational management database system? It's a database system that manages data as a collection of tables in which all relationships are represented by a common value in related tables. So here we have the various tables related. So the purpose of SQL standards is one, to give a general specific syntax and semantics for data definition and manipulation, define data structures and basic operations, enable portability of database definition and application models, allow for later growth enhancement to uh, standards. So if you want to, when we have one simple way of doing it, it's easy for all of us to contribute and then ensure that they improve. You know, so um, what are some of the benefits of having a standardized language? Reduce training costs. We don't have to train several individuals on different things. Once you're training SQL language, it's pretty much done. You know, increase productivity, application portability, application longevity, reduce dependency on a single vendor. So you notice that we have um, PostgreSQL, we have MySQL, we have SQL Server. All these are using the same SQL language. All right, and then it's easy for you to have cross-system communication because it's the same standards that are being used. Now, the SQL environment is have these various components. We have the catalog, that's the set of schema that constitutes the description of a database. And then what is a schema is the structure that contains the description of objects created by a user. Here we're talking about it is based on the tables, the view constraints. These are rules that govern it. Then we have the data definition language, the DDL. These are the commands that defines a database, and these includes creating, altering, dropping tables, establishing constraints, etc. And then we have the data manipulation language. These commands that maintain and query a database. We have a data control language, the DCL. These are commands that control database, including administering privileges and committing data. So you have quite a simple description of how a database works. All right. So with this, with a common program that or various programs, we're able to access our database, which is from here to there. All right. Using simple SQL language. So with the SQL queries, we're able to access the various catalog where you have ProC and DevC. That's a catalog of data, and we're able to access that. Again, we said that the environment enable us to access. So the DDL is more physical design, and then the DML is the implementation, and the DCL is when we do maintenance. So in essence, we say that data definition language, there we have where we define the database. So we create a schema where we define a portion of the database owned by a particular users. We create tables, we create views, and we can also create statements like a character set, collision, translation, assertion, and domain. Right. So based on the table, so one of the purpose of the DDL is to specify data types of each of the attributes where we have the columns or fields of a table. Now, this table shows some of the common data types, but there are many others. So we have strings, we have numbers, we have temporal, we have boolean. Strings, we are looking at characters, and there we usually say char, C-H-A-R, that the entry will be a character. We could also look at character varying, where we have varchar, which is a variable character, and then we have the varchars too. Right, we have that. Then we have binary large object, which is the blob. All right, so stores binary strings values in what hexadecimal format. So Bob is defined to be a variable length, and this is mostly in Oracle. Also have club, and then the NC club, as well as the B file for storing unstructured data outside the database. Yes, then we have numeric data, which we usually store them in integer, denoted by AINT. Storing numbers with a prefix precision or scale of what? 0. Then we have the timestamp. Temporal. Temporal is dealing with time, so for seconds, date, etc. Boolean values, we are looking at true or false, yes or no. And that's what we're looking at. So DDL is used to create used for table creation, and it allows you to implement all the items listed here. So everything that you see here, we use the DDL um, to create. And so in this table, we see it shows an overall structure of a create table statement. Now this shows that table would have a name, some numbers of columns, definition, and a table constraint. Right. So in the following slide, we would see several examples related to um, the Pine Valley Furniture Database. That's what we see mostly in this particular. So here we are creating a table, right? So create table with a name, right? And we are giving several other definition where column definition. So column name, we have a domain, the name, the defaults, that we are table constraint. We're telling what kind of constraint the table should have. All right. So all right, so we have this, all right, where we've created several tables. All right, so when you go through it, you notice there is the create table T, customer T, all right. So we've and then we are giving the various columns that will be available, and we are saying that it will have a customer ID, which is going to be number 11, right? 11 space. We have customer name, which is going to be a varchar 2 with a space of what? 25. Customer address, customer city, with the various definition attached to it. Right? Then the constraint, we're saying that customer underscore PK, right, would be what? The primary key. That's the primary key would be what? The customer ID. So overall definition of tables. We have um, defining attributes and their data types, similar to what we had in the previous table. And so you notice that here, so here, those what have been in the red outline is where we're defining the attribute, and then now means non not laudable what specified, and then below is the primary key can never be now. A primary key can't be now. So it means that we're defining at the top, we're trying to say that define product ID, but don't make it empty. So it means that you cannot leave it blank. You always have to fill it with something. And so again, some primary keys are composite. In other words, they are multiple attributes. And again, they also cannot be now. So not now. We're defining that. Controlling the values in the attribute, right? So here we're saying default value, right? So order date, default value is system date. And then we have a domain constraint, again, where check, we're checking certain things in there, and in order to conform with other. So identifying primary keys and establishing relationship. All right. Okay. So these are, the primary key of dependent what table is also specified. We're creating a new table, and then we make sure we specify that this is a foreign key in there, and we make reference to the table in which it is what coming from. So that's that. So when we check data integrity, it's referring to constraints that ensures that foreign key values of the table must match primary key value of a related table in a one-to-many relationship. All right. So restricting deletes of primary records, update of primary records, insert of primary record. These are various restrictions that we can look at. And so here we say that the create table statement include a clause to specify how update and delete are processed when there are dependent tables. So if a delete request comes for a record with dependent records in another table, then the database could restrict the delete, which means to disallow it, or it could cascade the delete so that that dependent record with matching foreign keys would also be deleted, or it will be set to now, which means that deleting a primary key record will result in setting all corresponding foreign key to be now. This would imply an optional in cardinality in the relationship. In other words, you have to make sure you specify that in the cardinality such that, because the primary key we know cannot be now. So if you're deleting and you allow everything to be deleted, they need to specify it in the cardinalities. Also, the alter command will be done after table have already been created. For example, if you have an existing database, even one with actual data in it, you can modify table by adding or changing columns, removing columns, adding constraints, etc. If data in the table violates the constraint, you will be prevented from setting these constraints until changing the data. So whereas create table is mostly a process that creates or takes place during implementation, alter table often takes place during what? Maintenance. In other words, when we want to maintain a table, that's when we do alter table. Then for the table will not be dropped if there are other tables that depend on them. This means that if any table in a foreign key or has a foreign key in the table being dropped, the dropped will fail. Therefore, we make a difference which order you drop the table in, right? So drop statement allows you to remove tables from a schema. But then if that table you want to drop is related to some other, well, that will be very difficult to go unless otherwise specified. And then we have the insert statement, which at the last statement shows it is possible to insert data into one table based on a query from another table. We'll talk more about the select statement shortly. So here you have the insert, which is at the end of the slide. So insert into customer T, select all from customer table, where what? The customer state is what? CA. And so, like I said, identity columns are columns whose value automatically what? Increment with each new insert. So an insert statement does not explicitly give a value for an identity column. This is handled automatically. Often primary keys are identity columns, but not always, which means in some cases they are incremental. So they are incremental by one. So once you bring in a new one, it automatically goes. So if it's an automated primary key, then you are using what? You use the identity column, because as you want to add a new one, the primary key automatically be increased. Then we have the delete statement. So delete statement removes row from a table. Delete certain rows. So delete from customer T where customer state is HI. All right. So remember, referential integrity rule will control whether a delete actually happens. That is the restriction or the restrict the cascade or set now constraint will determine how to what? Handle the order for a deleted customer. Likewise, update. We know that it would affect only one record in a table. How do we know this? Right. The answer is because the product ID is the primary key, which must be unique. So there can be only one product with product ID what? 7. However, many times update and delete affect many records. For example, delete from customer T where customer state is high will affect all customers from Hawaii, because HI is representing what? State of Hawaii. So that's it. So in the statement on the screen, we're going to update the price of a product which has the product ID 7, which means it's only one product that's going to, because that's a unique key. But when we now refer to where customer state is high, it means that all customers who belong to Hawaii are going to have their price standard, what? The product standard price updated to 775. Again, we have the merge statement, right? The merge statement, it's easy to update a table. It allows combination of insert and update on a statement. So the merge statement was introduced somewhere in 2008 to make updating a table easier. So many database application needs to update master tables with new data. So a purchase T table, for example, might include rows with data about new product and rows that change the standard price of existing product. So Upgrading product T can be accomplished by using insert to add the new product and update to modify what? Product standard price. That is in 1998 DBMS. But then in SQL 208, right, we are able to accomplish this by using the merge, and it performs update on the match record and insert on unmatched records. So with a schema, right? Schema definition. So here we're talking about control, process, storage efficiency. So all of this has to do with the physical database design. That is what we're looking at, the schema. So here we have what? Control processing, storage efficiency, where we have choice of index, file organization for base table, file organization for index, data clustering, statistical maintenance. So creating index, speed up what? Random sequential access to base table data. Example here is a create table name, table index, or create, index name underscore IDX on customer T, into bracket the customer name. So this make an index for the customer name field of the customer table. And so we have the various, right, select statements. So clause of a select statement, select from, where, group by, have it. And so these are the various queries that can be done on a single or multiple tables. So the select statement includes many features that allow you to perform sophisticated queries. So you can specify the condition of a row to be included in result, and you can choose which column from these row that should be included. You can either get detailed data or get aggregated results, such as the sum, average, etc. And you also have many options in how to sort, format as well. So here we have an example. All right, so the select clause specifies which column to return. So from clause specifies which tables these come from. Where clause specifies conditions that determine whether the role is returned in the result. And then group by or having is used to aggregate queries. Order by determines the sorting. Note that queries can also include subqueries. All right, so you can see a select inside another select statement. And that's the beauty of SQL. It allows you to do some sophisticated things. So we have this example here. All right. So find product with standard price less than what? 275. So here you would see that the where clause includes one or more conditions. A condition is a test that for each role in the table is either true or false. Only those with true values are permitted in the result set for the query. So you have select product description, product standard price from the product table, where the product standard price is less than 275. And that was the thing, where we want to output the product with standard price less than what? 275. And that's the query there. So, select examples. Alias is useful. This often saves you typing time when writing a query, right? So here you notice that alias an alternative column or table name. So select cost dot customer name as name, cost dot customer address from customer vehicles, sorry, where name is equals to what? Home furnishings. So these are select examples, right? And then we have this as a select example of Boolean operators and or, right? So select product description, product finish, product standard price from product T, where the product description, like, right, the wildcard, which this, the percentage sign, desk, or, so here we are comparing either where it is this or that, and including price that are greater than what. So that is it. So this is a Boolean query, a simple diagram that is showing the various. So by default, AND operator takes place before the OR. So only tables over $3,000 are included. All right, these are then combined with all desk, no matter the price. All right, that's the rule. So that's the rule. All right, okay. So again, an example of using with parentheses. All right. Yes. These override the normal precedent or Boolean operators. With parentheses, right, you can override normal precedent rule. So here we are saying that. So we're giving it a different feel. You notice that in this case there was no parentheses, but here we've given it a restriction. Work within the parenthesis first before you come outside the parenthesis. And this one, this is how it's going to be. So you notice that parentheses give a new definition. So the parenthesis causes the or to take place before the and. Therefore, first desk and table are combined via the or, and then the entire set is subjected to the 300 price limit via the and. So that's the difference. So when you're writing your queries, you have to be careful. Know exactly what you mean to do and then do it as such. So sorting results by order. An example we have here. So select customer name, right? So the question is, how can you order by any number of fields from the ordinary table? And the answer would be where state equals to or state. See, these are using the or statement, right? Yes. And then you are able to get that. Then we have categorizing result using group by. All right, so select customer state count from the customer, and then when you get it, you group by what? Customer state. All right, so with this query would return a single value, which is the total number of customers. That would be the sum of all the individual numbers returned by the aggregate query displayed in this slide. So here too, so we have group by having, and then the results here would also having clause restrict which group will be returned in a vector aggregate query. It's like a where clause but operate on a group, not individual. All right. So here we have this. And when you look at the sorry, the query from that table, so this is the result we're going to have. So we also have the views. Views provide user control access to tables. Base tables, the table containing the raw data, the dynamic view, a virtual table created dynamically upon request by the user. All right. So we have a copy or replicate, that is a materialized view. Data, and then must be refreshed periodically to match corresponding one table. And so we have this example of creating a view. Right? Yes. What are some of the advantages of a view? Simplify query command, assist with data security, enhance programming productivity, contains most current database data, and it used a little storage space, provide customized view for users, and establish physical data dependence. The disadvantage is that use processing time each time you view is preferred and may or may not be directly updatable. All right. So that brings us the end of the basics. And the next, we're going to be looking at what? Advanced SQL, which would be directly linked with our for final exams. I like to always stress on what you should learn for starting. So I wish you all the best and see you in the next lecture. Remember to always comment and send your questions and your comments. Thank you.